Hey everyone, and welcome back to the session. Now, let's go ahead and continue where we left off. So previously we were starting to work on the function called reduce and what exactly it does. And let's exactly take a look at what it does and um, what's the purpose of it and so on. Now, if you remember, we had a problem called two-sum problem that we did, right? That is we also had a problem where we calculated maximum sub-array sum and so on. All of these, wherever we use loops, some of them can actually be replaced by reduce method, which can perform the exact same operation. And this is what reduce method does. Let's consider a simple example to understand. If you have an array like this, or rather than an array, let's just say a list like this, the operation of reduce is it takes two elements at a time. Initially, it will only take one element. First time, it's just going to take one element. And okay, I'm so sorry. It's the opposite. I'm sorry for that. Initially, it takes the first two elements, not the first element. Initially, it takes the first two elements. Whatever operation you want to perform between them, you can do it. I want to perform addition because I want the sum of all the values within this list. Again, this is something that we can directly do. We don't have to use reduce for it. Reduce can instead be used to perform operations on all the elements in a cumulative way. Like if you want to calculate 1 into 2, whatever is the result, multiply it with 3, whatever is the result, multiply it with 4, the result, multiply with 5, and so on. These are specific cases. There are very specific use cases for this. It's not something you end up using on an everyday basis in a function constantly. So just something for us to know and understand to begin with. But moving apart from that, it's quite an important function and an interesting function to know and learn. So let's take a look at that. If my operation is to perform x plus y, in that case, it's going to take the first two elements initially, add them, and give me the result 3. After this 3 will become x. The next element will be considered as y. These will be added. It's going to give me a result 6. Then this will be considered as x, and the next value that we get, 4, will be considered as y. These will be added, we'll get 10. Again, this will be considered as x, and this 5, whatever we get, will be considered as y. Again, same operations, you'll add them and you'll get 15. That is the whole purpose of it. Now, um, this particular function, when we talk about reduce, whenever you want to perform maximum values, whenever you want to find the highest value in a list, the lowest value in a list, or you want to perform your own customized aggregation functions, which could be useful for your own, let's say, um, numerical analysis or so on, that's when you end up using them. Let's take a very small example to see how it works out and how simple it is to implement. A simple way to perform this is, let's say we'll take a list, and all that I'm going to do here is sum equals, let me not take sum. Let's rather take product, for instance. Product equals reduce. Again, same thing. Yeah, one more thing. Reduce is not directly available. You have to import it. One thing that you need to know. Reduce is directly available within Python 2 versions, not Python 3 versions. Within Python 3, you need to import reduce. That is, you need to go from functools, import reduce. This is what we take ahead here. So let's start with this. For functools or functional tools, let's import reduce. And now we have this function. Let's utilize it. Here, Let's perform a simple operation. Our array is nums, and the operation I want to perform on top of it is using lambda. Remember, this is a binary function. It's going to take two values at a time. So I have to take input as two values, and the output I want to perform is x multiplied by y. That's it. So whenever you get a question like multiply a couple of numbers, you can just use something like this. And this particular question might not be limited to this. As I uh, pointed out, it could be some custom aggregations that you use and so on. And here's why these functions are important. I'll just go on a best practice notion away from our basics to just tell you why this is highly important. If you've ever worked on PySpark is basically an addition, or it's basically a layer on top of Apache Spark that you can work on. For those who are not aware of Apache Spark is a framework rather than a frame. Yeah, we can call that a framework to begin with. Or an engine rather, that helps perform large-scale data analytics. The whole purpose of this is that it uses multiple machines, not just one machine. You can have five, six different machines, and whatever operation you are performing, it will divide your operation into all these machines and perform it. That's what PySpark does. So if there are, let's say, four to five different RDDs essentially as in resilient systems. Yeah, I'm just going to go through this in short. So resilient distributed data sets. This is the data structure. So whenever you create, let's say, a list or dictionary and everything, we convert it to RDDs in Apache Spark. That's because when you have RDDs, these RDDs can split across multiple computers that are available, like 33% of it to one, 33% to another one, 33% to another one, and it will perform operations in all of these and combine the result back so that you can get the result in a faster time. So a lot of large scale data analytics corporations use these. A simple example, think about this. If there are millions of people watching a live show, take it as NFL or whatever it could be. If it's an app, it might show, let's say, 300,000 viewers are watching, and they're interacting with the app and so on. So when a lot of such things happen, huge amount of operations are done. Generally, PySpark is one of the common things that is used to make sure that with such large set of operations, large set of user-based operations that are to be performed. You want to keep a count of them. You want to perform these things. You can do that using RDDs and multiple systems so that the time spent on it is much, much lesser. That's one thing you just need to know. And PySpark on top of Apache Spark, make sure that functions like map, filter, and reduce have default ability in the functions to split across multiple systems and work on them simultaneously. So these are some additional things that if you know, you can utilize it in the future. For example, I'll just check this within a minute because I really don't want to spend too much time away from basics of Python. But I don't want you to think like, okay, I'm learning reduce, but I have absolutely no clue where I'm going to use this. If it's just a small function with a very niche category, what's the purpose of me using it? So that's where I want to make sure that such thought processes are removed. So if you take a look at PySpark, reduce, so hey everyone, apologies for the slight delay. My microphone just got disconnected, so I just had to rejoin. Otherwise, Teams does not detect it by default. Yeah. So let's get back. Yeah, we were here, right? PySpark reduce function. So in PySpark or Apache Spark, you have reduce for RDDs, which you can use, and this reduce is gonna internally divide it among multiple systems if you have and work simultaneously, so that you don't have to manually do all of those operations. And it's the same thing, just use reduce with the exact same logic as we did before. It's a binary operation, perform it, as simple as it is. So this is one other way where you can actually use it in real life to perform parallelized operations, as I said, in multiple PCs, for example. So yeah, these functions, whatever you get to see here, these are the kind of functions we often get to use in large scale applications, and specifically within large scale applications for you to perform operations simultaneously. That is within multiple PCs by splitting up the data and taking it up. There are a lot of things that we can do within this. This is just one such purpose. Anyway, let's get back to our current example and try to work around. And let's print product. Now, when I run this, you get to see for reduce, it's not a reduce object. The reason why it's not a reduce object is because reduce returns a single value. Map and filter return their own object which have multiple values or elements in it. But reduce returns a single value or a single element, which makes it fairly simple and straightforward to understand and use, because you don't have to necessarily use reduce in such a way that you're going to get multiple outputs. It's going to perform some aggregation and give you a single response. Hence, there's no such reduce object. You get a single response of whatever data type it is that you provided as input. That's how it works. With this, let's go ahead and try to learn further about certain functions. Now, the next and highly important function that I want to provide to you. Okay, before this, I'll just summarize map, filter, and reduce for us. So map, filter, reduce. These functions apply a function on iterables. That's what they do. Map pretty much applies a function over all items of iterable and just provides the response. Filter filters the iterable based on the function. Reduce applies a binary function to aggregate data. That's pretty much all we need to know about this to begin with. Now, with this, let's go ahead to a specific function called yield within Python. Now, first thing, um, yield is called a generator function. Now, this is where I will go back to refactoring.guru to just um, walk through one little part of this. There is code examples here. You can see a lot of different patterns you can look at and understand. So this again, it's a link I've shared in prior, and I would highly suggest everybody to walk through this. I would highly suggest everybody to take a look at this and see how useful these are, because in real world applications, when you develop, you will end up using these. You'll definitely end up using these. So there are things like decorators, for instance. The idea of decorator is you apply a function over a function like this. You add a property like this, and that property will help perform another operation on top of a function. We'll see a few examples of these ahead, but prior to that, The moment you start looking at these, initially they might be complicated. So just take a look at their articles first, read and understand what is the purpose of decorator, what is the example of it, what is it used to do. Then take a look at one, once you have learned this entirely, then take a look at one of the example within, let's say, Python. That is how I would always suggest anybody to work around this. Same goes for refactoring, which again, I'll provide some further details ahead in time. Let's not take too much time away from this. So yield comes sort of into this category, which is uh, applicable within the context of generators. It's a part of generators. Now, a generator function is a specific function that allows you to output values from the function while still executing it. Generator function, let's say, allows producing values from a function while preserving its state, or while still executing, you can provide an output. I'll give you a simple example for reference for us to understand what is it and why it is used. Think about this. You have an iterable, and for each element of the iterable, you want to perform some operation. Let's say there are four iterables. For each element of the iterable, you want to perform an operation